This is the first most missed set we're going to do. It covers 4 things you've done in the last 2 weeks. The first comes from the quizzes you took about 2 weeks ago where there were 25 multiple choice questions, and I picked the 3 that you guys missed the most. My guess is this first one would be fixed because we reviewed implicit just a day ago, but we'll run through it anyway. So I'm supposed to take the derivative. I like to show the formal notation when I'm doing implicit just in case it still isn't quite clear to some of you. The derivative of any constant with respect to anything is 0 because constants aren't changing, and a derivative is a rate of change. So when I do the derivative with respect to x of x squared, it's 2x times the derivative of the guts, which is dx dx, which is 1. This is a product. So I need the product rule. I need to do first d second plus second d first. And you can see that that d first is 1. It's with respect to x. So that would be first d second plus second d first. And we kind of go y prime. But I just wanted to show that formal notation. And be careful if that had been a subtraction there. That's pretty common. You have to put that in parentheses then. And then we have minus. Again, it's the derivative with respect to x of 3y. So it's 3 times dy dx, or 3y prime. Maybe some of you, now after we've done it a few times, are going, oh no, I remember. All right, so we are supposed to find it at a specific point. So I'm not going to manipulate it anymore, just in case I do it incorrectly. I am going to go in and I'm going to replace all my x's with a 2. And I'm going to replace all my y's with a 1. And then I'll solve for y prime. So when I do that, I'd have 4 plus 2y prime plus y prime minus 3y prime is equal to 0. So when I add these up, wait a minute, that wasn't a y prime, that was a y, excuse me, and my y value was 1. So when I work this one through, I have 2y primes minus 3y primes, so I have a negative 1y prime, and I have that equaling a negative 5. When I divide both sides by negative 1, I'll get a 5. So that was just a straightforward implicit problem. My next one is sort of that you know what the notation means. So this says the average value of a function is 12. So I would write out what that means. It's 1 over b minus a, 4 minus negative 2, times the integral from a to b of the function, and they're telling me that's 12. All right, so what do I know about the function f of x? Because I need to take 1/8, technically, because constants can come out front, of just f of x dx. So if I multiply both sides by 6, I'll know that the area under that curve before I averaged it out was equal to 72. And this one says I'm supposed to do 1/8 of it, or divide it by 8. So my answer for 1/8 of the integral from negative 2 f of x dx is 9. And then this one is the limit as we go to infinity. On the top, when I send x to infinity, the top goes to infinity and the bottom goes to infinity. What that means is this needs to be L'Hopital. L'Hopital is used for 0 over 0 or the plus or minus infinities over plus or minus infinity. All right, so it's not just 0 over 0. That tends to be how it's tested the most, but that's not always the case. So I need to do the derivative of the numerator. The derivative of the natural log of a function of u is 1 over u times du dx, or equivalently, u prime over u. And in this scenario, my u is this guy. So I need to do its derivative, which would be e to the 3x times 3 plus 1 over 1. Oh, sorry, over e to the 3x plus x. Both of those are still going to infinity. So technically, I should L'Hopital again. And I get e to the 3x, and then times 3, so I'd have 9. The 1 will go to 0. On the bottom, I'd get 3e to the 3x plus 1. You could actually stop right here, because plus 1 does nothing, and these are tied. As you go to infinity, that plus 1 on the bottom is not going to do anything. So I can see it's a 3, but if you wanted to, you could still L'Hopital it one more time, because you still have infinity over infinity, and you'd have 27e to the 3x over 9e to the 3x, and then the 1 would go to 0 on the second, or third actually, iteration of L'Hopital's rule. Now these are for sure tied, and my answer is 3. So you could have quit at the second iteration, but you didn't have to. This one is calculator active, so take out your calculators. And it says let f be the function f of x equals 3 to the x. If the values in the table are used to approximate the derivative at 1, just a second, I have to pause this, my phone is ringing. All right, I had a phone call, sorry about that, so I'm back. Let me remember what we're doing. Oh, we're approximating the instantaneous rate of change at 1, or the slope of the tangent line. The only way we can approximate off a table is to do what I call straddle it, and you do slope from algebra 1, change in y over change in x, which would be 8 over 2, which would be 4. That's my approximation using the table. I found the slope of the secant line between those 2 points. But this says, what is the difference between the approximation and the actual value? Now you have a couple ways of doing this, and I'm going to show you both. Because this is calculator active, I believe, because of the decimal places, you could just do math 8, and it will tell you what that is. I'm going to have to write it down, just make sure you do it. Or, if you didn't have a calculator, I want to discuss again how you do the derivative of a to the x. If a is e, it's e to the x. But technically, if I were to show you the proof, which this isn't the time, but I think I'll do that sometime soon, there would be an ln e in front of it, and ln e is 1. So this derivative with respect to x of 3 to the x is 3 to the x, just like e to the x is e to the x, but it's times ln 3. So when x is 1, we'd have 3 ln 3. That'll give you the same answer as doing it on your calculator. You need to subtract the 2 to find the difference. So I will let you, keeping it real, do that, and that'll be one of the questions I ask you. All right, next one up. It says the graph is the function of f. This was part of an FRQ from last week, and I want to look at part B. All right, so I'm given the graph of f. That's important to know. It says find the value of, and it's got this limit here. There's a couple ways you could approach that. You could go, oh, well, when I put in a 0, I get 0 over 0. This needs to be L'Hopital, which would give me f prime of x minus, and the derivative, this is a y value at 0. It's a constant. On the bottom would be a 1, so I'd say, well, that's just the derivative at 0. Or you might recognize that as the formal definition of the derivative of the function f at 0. Either way, if you didn't recognize it as that, so they're asking you, what is the derivative right here? And your eyes see the cusp, and I have to see what the prompt is. It says, give a reason why. That's a little bit more robust of a prompt than to explain, but not quite as big of a prompt as justify. But I'm going to use limits to explain it. It's because when I come in from the left, and not of f of x, because actually the limit on f from the left and the right is 0, but it's the derivatives or the slopes that aren't matching. So that's not equaling, sorry, my screen does not like it on this side, so hopefully I'll write it. X approaches 0 from the left of f prime x. Those are not equal. Okay, so therefore the derivative doesn't exist. I know that because I see a cusp. I'd hesitate in writing that word cusp. Okay. Next step, we're moving on to number 29. By the way, these are from, I don't remember which set of data, but this, pay extra attention because you indicated on one of the Google Forms for 2008 that this same skill was a struggle, and I'm not going to do it. So one of these questions, you might want to write this one down in full and pause the video. So we've got f and g, and they're both continuous and differentiable. This word isn't needed because differentiability applies continuity. With f of x equaling the inverse of g. Okay? So f of x is the inverse of g. All right. I am supposed to find the derivative of g. Okay? We've got to think about, well, if f of x is g inverse, then g is f inverse. It works both. That's how inverse functions work. Meaning that if the square root of x is the inverse of x squared, well, then x squared is the inverse of the square root. So that it works both ways. So what I know is that my g's derivative, right? And what is g? It's the inverse of f. So basically, I'm looking for the inverse's derivative at -2. So here's what I know. Derivatives are slopes of tangent lines. I'm doing it at the x value of -2. So I know that -2 comma something has to be on f inverse, or equivalently g. Well, inverse functions swap the x's and the y's. So that has to be on the other function, which is f. Okay? So I need to see who got mapped to 2. F of what is 2? No, here it is. So 5 is my missing value right here. It's also right here. So those are my 2 corresponding points. The derivatives of inverse functions are reciprocals. At corresponding points. So there's going to be enough information for me to figure out, well, what is f prime at 5? I go up here, and it's probably handed to me. There it is. F prime at 5 is equal to 4. Well, that means at its reciprocal, -2, at the inverse, the corresponding point, I would flip it, and it would be 1/4. We showed that when we did this skill, by the way, gets forgotten every year. There's really no way for me to get it to stick for you except to just keep saying over and over again that if you're doing some inverses functions derivative at some place, it means 3 comma, or that place comma something is on the inverse function, which means something comma 3 is on the original function. This you'll be able to find either off a table, off a graph, or you'll actually say, well, what gets sent to 3 if it's x squared plus x plus 1? And you'd say, well, looks like 1 would. You say, oh, okay. And you'll be able to find the derivative at 1, either off a graph, or in this one, these pre-measured bowls, or off a table, or on this one. I would have to actually take the derivative and put in a 1, and I would get my derivative of 3. That is on f, so its inverse's derivative would be 1/3. So that's our process for that. Okay, our next one up was number 89 on one of them that you guys indicated was a struggle. So let's go take a look at this one. It's tabular. What do I know? I know that f prime is greater than 0, which means f has to increase this whole way. Let's go see if any of this one's out right there. All of the rest of them meet this criteria, so that's not helping me much. Okay, next thing is that the second derivative is less than 0. A second derivative is less than 0 if a first derivative is decreasing. All right, so I have to see which value when I put in there would cause my derivatives to decrease. I'm just going to do it by trial and error. I think I'll put the 28 in first just to try it. And I'm going to do the slope to the left and the slope to the right. Okay, and the slope to the left would be 4 over 2, right? So 4 over 2. By the way, this is 6 over 2, which is 3. This is 12 over 3, which is 4. So you can see that my derivatives or my slopes are increasing right there. When I put in a 28, I'll have a 4 over 2, which is 2, still decreasing. But then I have to check over here. I'd have a 4 over 2, and it's still a 2. So that didn't cause it to decrease over there on that side. Again, for a function derivative to be less than 0, the function has to be decreasing. In this case, my function's f prime. All right, so now I'll just try 29. I actually don't know which one works, but on 29, I'm going to go my derivative, or my slope would be 5 over 2, 2.5, and over here would be 8 over 2. Wait a minute. It's not 8, it's 29. Right there. Sorry, I don't know where I got the 8 from. All right, so over here, when I put in a 29, I get 5 over 2, or 2.5. For my slope over here would be 3 over 2, or 1.5. That is causing my slopes to decrease, which means their derivatives are negative. So my answer is D. That one was tricky. All right, next one up. You guys said that was most missed, or that you struggled on the most on the Google form was this guy. So let me see what I've got. I've got some parabola that opens up. I've got at the line x plus y equal k being tangent to the graph someplace. So this is x plus y equals k. And this over here is my y equals x squared, blah, blah, blah. What is the value of k? Well, if it's tangent, it's slope. Okay, so I'd have to solve for x. So my y is my slope is equal to -1. Well, a derivative is the slope of the tangent line. So I'm going to take my derivative, which would be 2x plus 3. That'd be my y prime. And I've got to set it equal to -1. So 2x would equal -4. X would equal -2. All right? So it says x is equal to -2. I don't go circle that because it says what's the value of k. So I need to go get y. Well, this point right here, it's on the line and it's on the curve. It's on both of them. So for me to get my y value, I have to put a -2 in for x. So I say y equals, I have to hop on this parabola right here at -2 comma, whatever the height would be. So that would be -2 squared is 4, and then it'd be -2. Again, I'm putting it in for these x values. I am putting in the -2 that I just found. So I have 4 plus a -6 plus 1. So it looks like I have 2 plus 1 or 3. So when I'm done, I have -2 plus y equals k. That gives me a k of 1. I like that problem a lot. You have to really understand what a derivative is. It's the slope of a tangent line. Okay, and that point of tangency is on both the function itself and the tangent line. Remember, if we're concave up, our tangent line gives underestimates when we vary from the point of tangency. When we're concave down, our tangent line will give us overestimates. That wasn't asked, but it's a good time to review that. This was another one that you guys said was one of your harder ones. So let's go take a look at this. We've got a function that's continuous. That's important. It means I cannot lift my pencil. From -2 to 2, I will not lift my pencil. Again, I like to draw these graphs if I can. F of -2, the y value there, and f of 2. So what it means is I'm starting and ending at 0. I can't lift my pencil, and there's no place where the derivative equals 0, which means whether I go down first or up first, and I can't lift my pencil. It means there's no place where I do that smoothly, because if I did, I'd have f prime of c equaling 0. Well, what that means then is that I couldn't have done it smoothly. It means they have to be connected without lifting my pencil. I have to either go up, or maybe it's going all over the place, but what goes up must come down, and if the derivative, and vice versa, what goes down must come up if I don't lift my pencil and start and end at the same place. So what that means is I had to have a cusp. So it says which one of these is true. It means the derivative doesn't exist somewhere. Okay, so let's go see which one says that. I don't know that the function's increasing the whole time. I don't know that it's decreasing the whole time. It doesn't exist everywhere because I had to go up and come back down, and I couldn't do so smoothly because the derivative couldn't equal 0. The function is continuous. So here it is. For some value, there must be a place where the derivative doesn't exist. Has to happen at least once if I have to go back to the starting point without lifting my pencil, and I can't do so smoothly. And I think this is our last one. Yep, so last one. I was hoping this would be 20 minutes, but it's 21. All right, so this one says I've got a twice differentiable function, which means it's continuous and I can take its derivative twice. It's telling me that the derivative at 3 is 2. So I'm going to go here. The derivative there is 2. The derivative here is 2. The derivative here is 2. Notice how I piece apart the information. And if it's a graph, I put it on a graph. If it's a table, I put it on a table. I know that my derivative at 3 has to equal 2. That's what this is telling me. I've just used that. I also know that the function is concave down everywhere. You might say, I'm going to go graph them all and see which one's concave down. They're all really close. You wouldn't be able to tell. All right, so what you do need to know is that when f prime is less than 0, it means f prime must be decreasing. So we're going to go find the slopes above and below, and we're going to make sure that we are decreasing. This would be 2.5 over 1. This would be 1.5 over 1. So it looks like, oh, sorry, that's 2.5. Yeah, that's right. 2.5 over 1 is 2.5. And then 1.5 over 1 is 1.5. Let's go check this one over here. All right. I would do 2.5 over 1, which is 2.5. Again, I'm just subtracting. And this would be 2 over 1, which is just 2. This one didn't decrease. I'm just checking all of them so you can see it. This one would be, again, 2 over 1. That didn't decrease. Went from 2 to 2. If you check them all, this is the one where the derivatives are decreasing. And if a function is decreasing, its derivative is negative. All right, so I was looking at those slopes on the graph. So we are done. That's the end of your ed puzzle. Ed puzzle. Done.